So we're going to finish up yesterday's. Well, it looks like a lot. I'm going to have to chop some of that off. Okay, so we are learning target today. Again, we're going to be using the arc length formula. To solve story problems. And we are going to discover a formula to find the area of a sector of a circle. So yesterday we found the arc length on the curve. Now we're going to find the area of that pie piece today. So to discover a way to find the area of a sector. I would definitely be reading your learning targets when you go through to make your note cards, because these are the things we're doing in the section. If you feel good about them, you don't have to put it down, but let me make that a little smaller. Okay, let's continue from yesterday. Story problem, couple story problems. We know the process is the fraction of the circle times by the circumference. We're going to talk about the Earth, and we're going to look at towns that are on the same longitude line. I think about it. Up and down lines, longitude, latitudes go across. Okay, so they're going to be on the same longitude line. So that would be like the arc length on a circle if we took that cross section. So towns on the same longitude line. Okay, we're going to look at Farmersville, California. Farmersville, California has a latitude of 36 degrees north, and then Pentagon, British Columbia is on a latitude of 49 degrees north, but they're on the same longitude line, so one's directly north or south of them. Okay, see that? But they're on different levels of the Earth. Okay, so they're connected on a longitude line, but one's higher than the other one on that same line. All right, so the goal is to find the distance between these two towns. All right, so let's take a cross section of the Earth. So I've sliced it right down on that longitude line, so it's flat for me. How do latitudes work? What does this 36 degrees north mean and 49 degrees north mean? Up of what? Up from? The equator. The equator's 0, right? So you've got your equator, that's 0. Okay, so Farmersville is at 36 degrees north of the equator. So if I swing up 36 degrees, that's going to be Farmersville. If I go up 49 degrees, that's going to be that Pentagon, British Columbia. So that whole thing from the equator up was 49 degrees. And you can see, because they're on that same longitude line, that the distance between them is just the arc length of a circle. Arc length on that piece of pie. So the piece of pie we're talking about is right here. That little sliver up there. So to get this arc length, we need the fraction of the circle times by the circumference. So the same thing we did yesterday. Well, what's the angle measure of my pie piece? How do I get that? You got to subtract them, right? 49, the two together, the bottom part's 36, so 49 minus 36 gives us a pie piece of, is that 13? Okay, so I got 13 degrees. How do I get what fraction of the full circle that is? It's my bottom whole. Allison? Divide by 360. Then we're going to multiply by the circumference of the Earth. Well, circumference, 2 pi r. 2 pi. I did not give you the radius of the Earth. I'll give it to you once. They don't tell you in all the story problems either, so so you got to use this number all the time. And they're going to go with kilometers. So they're using 6,400 kilometers as the approximate radius of the Earth. So we're looking at two big answers here. So 2 pi, the radius is going to be 6,400. And now it's just calculator line. And 2 sig figs. $1,500. 1,500? Okay. Good. I'll give you another one now. Same idea on the Earth. Number 2. Alright, let's go with, we've got Madison, South Dakota. Madison, South Dakota, and Dallas, Texas. Are 1,200 kilometers apart on the same north-south line. 1,200 kilometers apart. Let's see. The latitude of Dallas is 33 degrees north. What is the latitude of Madison? Okay, it's very much like the problem we just got done doing, except this time they're giving me the arc length. We're going to have to work backwards to find the angle of our pie piece and then turn that angle back into a latitude. So if you draw a picture, this isn't too challenging. So we've got our cross-section of the Earth. We've got our equator. And we've got 2 towns, Madison, South Dakota, and Dallas, Texas. Both are north of the equator. Which one's farther north? You've got to use your geography skills. Madison, South Dakota is going to be farther north. So we'll put Madison up there. Dallas, Texas is south of that, but north of the equator. And we know this is 33 degrees. And we know the distance between them is 1,200. I'm good at math! Well, I didn't say I was a calculator.
Are you kidding me? 18.
Try 52. See how that works for you. All right. Okay, so that's everything we've got. Our goal is to find the latitude of Madison.
Schwartz is the radius 64.
Oh, yeah, 64. See, that confused me over there. Threw me off my game. Screwed me up. Okay. So our goal is to find the latitude of Madison. So the final answer to the question is going to be, well, how far north of the equator is Madison? That's what we want to know in the end. Well, our formula is not going to tell us that directly. Our formula only works with this piece of pie. So, because I know the radius and I know the arc length, we are going to be able to find the angle in here. That's what we're going to be able to find. After we get that, it's a very easy step to get to the latitude. Everybody good? Okay, so we know our arc length is 1200. We don't know the angle measure. Remember, we're doing the fraction of the circle here. So what's my bottom value going to be here? We want degrees because latitudes are given in degrees. So we want 360. So we want this fraction in degrees and not radians. And then we multiply by the circumference. So times 2 pi r. And if you remember yesterday, I would multiply by 360 first to get rid of the 360. We'll probably just do everything all in one line. So times by 360 to eliminate that. Times by 360 over here. And then at the same time, how would we get rid of this chunk 2 pi times 6400? We're going to divide by, in parentheses, that whole chunk. Because if you don't have the parentheses, it only divides by 2. I hope that wasn't too messy there. So what do you get for your theta?
Wait, so the 2 pi times 64 r get multiplied by 360?
Nope, the 360 gets multiplied by the 1200. That's our numerator, so technically I could have parentheses there. Because that's what happened first. And then we come back through and we divide by that chunk. So if you wanted to type it all in one line. And we're looking at 2 sig figs, so how many degrees did you get? 11 degrees. Now go back and look at the picture. 11 degrees is not the latitude, that's just the angle measure between the two towns. So if this is 11 degrees in here, how do I get the latitude for Madison? Add the 33 onto it, because I need to come from the equator. That's 33 plus the 11. So the latitude for Madison is going to be 44 degrees north of the equator. Okay, number 3. Okay, we've got a pulley that's like a hoist. You turn the crank and it raises something up off of the ground that you need help with. So we've got this pulley. Let's see, we're going to find the radius of a pulley if a rotation of 75 degrees raises the crate 14.3 centimeters. Oh, okay, that's a small pulley. So, get a picture of what we got going on. So we got this pulley that's got coil wrapped around it. And off of, there's a string, or rope I should say, and then there's a crate down here. So the string hangs off of the pulley right there. So what we're going to do is turn this 75 degrees. So this point is going to wrap around to about here, 75-degree turn. So that means that rope on it's going to wrap around the pulley and it's going to raise that box up in the air. You got a vision of what's happening? Okay. So I got the 75 degrees. I don't know the radius of the pulley. What is this 14.3 centimeters that this is going up in the air telling me? Ben?
That you're 75 degrees, 14.3, out on the edge.
Out on the edge. So that 14.3 is our arc length, is what I was going for there. So, because that's how much rope is going to wrap around. So that 14.3 is the amount of rope that gets wrapped around the edge of this pulley, so that is our S value. Now it's just a simple arc length that we work backwards from. We know the arc length is 14.3. We know the angle 75 degrees out of a possible full 360 to get our fraction of the circle. And then times by the circumference, which is 2 pi r. And I always like to make the fractions line up. Now it's just algebra working backwards, solving for r. First step, times by 360 to get rid of that. And then what are you going to do after that? You can. 360 times 14.3. That'll give you 150 pi times r. And divide. Parentheses needed or not needed? Absolutely needed. There's two values there. If you don't have parentheses around that, all it does is divide by the 150 and then multiply the answer by pi. $11. Any questions through that algebra?
We need 3 sig figs.
Probably 3 sig figs, yep.
10.9.
10.9. Any questions through the algebra? Everybody get a chance to try it that wants to try it? Still on arc length. Good? And on paper. Yesterday. Three. Okay. We've got two gears stuck together. So pretend there's little teeth, you know how they fit together? So when one turns, the other one turns. And here's what we know about our two little gears. The smaller one has a radius of 11.7. The bigger one, we're going to look for the radius. So they're in contact here. If I turn the small one 80 degrees, so if I was to take this point, crank it up to the 80-degree spot, this one will turn 50 degrees. So this point go up to about the 50-degree spot. And our goal is to find the radius on the bigger one. Any ideas how we can attack this problem? Ben?
Go 80 over 50, and then multiply that by 11.7.
So you're doing proportions.
Yeah.
That will work. It's one way to do it. Like method 1. So he's thinking proportionally, and that will work on this. So you said, like, will it work that way? 80 over 50. So he went angle to angle, and he's going radius to radius. Do a little cross product. Tell me what you come up with. I don't have it done that way, but that seems like it should work. That's a little quicker than the way I was going to do. Tell me what you get. Because you're going to like Ben's way a whole lot better than mine. Final answer? Or
I got 18.7.
Yeah, I was checking.
okay, 18.7 is correct. So 80 times R and then 50 times 11.7. I don't have any of this work because I didn't do it this way. And then divide by 80. 18.7.
Short certificate?
I got 7.31.
Yeah, I got 7.
Do I have something set up wrong?
Yeah, I would have to say it with the 50 up.
That's where it is. Yeah, I was going to say, this should work. So 80, yeah, 80 over 50, 11.7 over the R. There we go. That's going to be better. So 80 R. Oh, it just did it again. My God. The 80 is with the 11.7 though, isn't it? It's not coming out right, is it?
No.
So it doesn't really work, does it?
No.
So if I had it, because I did have it, because the 80 should match with the 11.7. So it doesn't work your way.
Wait, shouldn't it work if you just go like 80 divided by 50, and you'll get like 1 point something, I think it's like 1.6, and then you just multiply with like your R by 1.6.
But why doesn't this do the same thing? Because that's usually why we set up
Yeah,
proportions.
it should be.
I have no idea.
I don't know
That's why I
either.
did it in my calculator.
That is going to work, but I don't...
It's because math, science, rules are laws.
Right. But if doing proportions, we always do, you know, the corresponding parts to set it up. I guess I don't like it. I don't like it.
Blame whoever came up
Okay.
with proportions.
All right. I don't like it. I don't like. You can do, if you like that, you go with it. I don't like it. I'll go with that. Okay. So I'm going to go back to the way I was going to do, the way I have it. Thinking about arc length. I don't like it because it doesn't match like the proportions like we've been taught all the way through. Corresponding part like the small over the big should be small over the big, and it's not coming out. So that's why I don't like it. But if you think logically about it and say, well, I know this has to get bigger, so when you divide and get the bigger number, you can make that work. This way over here that I was going to teach it will always work. So this distance here that this thing rotates is the arc length. But think about it. This one would have to turn the exact same amount. So what they have in common is the exact same arc length. Do you agree with that? That those two distances have to be the same. If you agree with that, you have enough information over here on the small one because you've got the angle and you've got the radius. You can find the arc length, how much it turned. So we're going to do that. So method 2. So the arc length, we'll first find the arc length. It's going to be a lot more work than this over here, but this, I don't know. We'll go with our fraction. 80 over 360, multiplied by the circumference, get the arc length, and we're looking at 3 sig figs, even though it looks like 1, but usually when they do the 80 and the 50, those are exacts, and they don't show us that they are, but we're going to go 3 sig figs. Tell me what you get. 16.3. So now we know the arc length on the big one is also 16.3. And we've got the angle so we can find the radius. So our second step is to now use that 16.3 in the bigger circle, 50 over 360, times by 2 pi r. So now we can multiply by that 360 to get rid of it. So 360 times 16.3, that's going to equal 100 pi r when I multiply the 50 by the 2. Divide by 100 pi in parentheses. And then we'll have the radius, which Ben got earlier, 18.7. I think I'm going to skip that and go to area. All right, switching gears now. Finding the area of a sector. This was our second learning target today. So we'll think about it logically, and then we'll come up with our plan. I'm going to tell you this circle has an area of, let's go 100 square inches. Full circle, 100 square inches. Again, if I cut it in half, you know the area is going to be 50 square inches. If I take out a 90-degree piece of the pie, what are we going to have? 25 square inches. If I was to take a more normal piece of pie, like .30 degrees, how big would the piece of pie be? How are we going to figure that out? How could we figure out how many square inches would be in this slice? Jimmer?
Would it be 30 over 360 times the total area?
Absolutely. Same concept. It's a fraction of this full circle. Well, what fraction of the circle is it? Well, it's whatever fraction 30 out of 360 is. So that would be 1/12. It's 1/12 of the circle, so it's 1/12 of the full area. And whatever that comes out. What's a 1/12 of 100? about 8.3. So our plan to find the area of a sector very much like arc length, you're going to take the fraction of the circle and multiply it by the area of the circle. So you need to know the, well, you don't need. So the area for the fraction, if our angle is in degrees, you have to take it out of 360. And what's the formula for the area of a circle? Circumference is 2 pi r. What's area? Pi r squared. Or if we are in radians, if that angle measure is in radians, what changes? If I said that was like pi over 6 instead of a degree, how does my fraction change? It's over 2 pi, because a full circle in radians is 2 pi. And then times pi r squared. Well, what happens here? Just the pi cancels. You still have that divide by 2 in there. This I want to add to your little blue book. And I'm just going to do one example. I think we're going to hit a little bit of this on Monday too. So we've got arc length in here, and now we're going to have area. And I put them on the same page because they kind of relate to each other. Area of sector equals fraction of circle multiplied by area of circle. So it's the degrees over 360 times pi r squared, or radians divided by 2 pi multiplied by pi r squared. I think I'm just going to do one. Then we'll finish this up Monday. That's fine. Good? I want to give you a little time to get started. Let's try one. What number am I on? 5. Okay, here we go. I'm going to make it a challenging one. I'm going to give you a pi over 4 radian I'm going to give you the area in here. The area is 36 square inches. Can you tell me what the radius is? We're jumping right to the challenging one. So we're just going to plug into our plan. We know that area equals fraction times the area of the circle. The area of the sector equals the fraction multiplied by the area of the circle. That's our plan. Well, we know the area of the sector, it's 36. How do I get the fraction of the circle that I'm dealing with if I know that the pi piece is pi over 4? Divide by the 2 pi full circle. And then we multiply by pi r squared. We don't know the radius. But line stuff up so you know what's going to happen here. So the first thing I would do is cancel these pi's out. What do you think's the next thing I would do? Multiply by 2 to get rid of that divide by 2. So then I don't have multiple fractions that I'm dealing with. So this will be 72. Then what I've got over here is pi over 4 times by r squared. What do I do now? Divide by pi over 4, which is the same as multiplying by 4 over pi. So that'll be r squared, whatever that comes out, and then what? And then square root it. And then square root that. And we are looking at 2 sig figs. .6. Okay, so I jumped to a hard one there, but hopefully you'll do fine. Okay, that was a long set today.